Hi, welcome to Angles of Elevation and Depression. Again, I apologize for the technology, but we are working on getting what we need as soon as possible so that we can get back to regular business. But let's get started. Let's use our trig to find missing sides using angles of elevation and depression. First, we have to understand what an angle of elevation and depression are. An angle of elevation is just like what you think of with the word elevate. It's going to rise. So it's the angle formed by a horizontal line and the line of sight to a point above the line. So if you look down here at the bottom in this diagram, angle 1 is an angle of elevation. This dotted line from the airport tower is our horizontal line. Notice, we have to start at the horizontal line and go up, so therefore it's an angle of elevation. An angle of depression is the angle formed by a horizontal line and the line of sight to a point below the line. Just like depression, you are pressing down. So here's our airplane, here's our horizontal line. We have to go down to see our object. That is your angle of depression. Now I want you to take a minute and think about how you can prove that angle 1 is congruent to angle 2. Pause the video and jot down some thoughts. Hopefully you remembered that, hey, parallel lines with a transversal create congruent angles. Angles 1 and 2 are alternate interior angles. And we remember that alternate interior angles and parallel lines, they are congruent. So anytime you are given an angle of depression, you could turn this triangle around to here, and this angle is now this angle. Let's take a look. So here is our diagram. Let's classify each angle as an angle of elevation or an angle of depression. So let's take a look at angle 1. Here is angle 1. So first we need to identify the horizontal line, which is this top dotted line. From here, we have to go down to get to the other side of the angle. So angle 1 is an angle of depression. Angle 3, here is the dotted horizontal line. To get to the other side of the angle, we have to go down as well. So this is also an angle of depression. Now angle 2 uses the same horizontal line as angle 3, but to get to the other side of the angle we have to go up. So angle 2 is an angle of elevation. Now I want you to try looking at these two angles here with this diagram. Pause the video and identify angles 5 and 6 as an angle of elevation or depression. To help you see, angle 5 is this angle here. Angle 6 is this angle here. Pause the video and identify those two angles. Now hopefully you got angle 5 is an angle of depression because here's our dotted line or our horizontal line and we had to go down to get to the other side. Angle 6 is an angle of elevation because we had to start at our horizontal line and then go up to get to the other side. You need to be able to identify the angles of elevation and depression so that way you can solve different scenarios, such as this one. The Seattle Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? And then want us to round to the nearest meter. So we need to draw a picture first. If we have the Seattle Space Needle, which is a tall building with this little tower or whatever up on top, well, if it casts a 67-meter shadow, shadows are on the ground, so here's 67 meters. And we have an angle of elevation from where? From the tip of the shadow to the top of the Space Needle. So that means we got to go from the tip of the shadow to the top of the Space Needle. And that angle of elevation is 70 degrees. And they want us to find how tall is that Seattle Space Needle. Well, hopefully you see that we have our angle. We're trying to find the opposite side, and we're given the adjacent side. And if you write your SOHCAHTOA, hopefully you notice that tangent is the one that we need. So we set up our equation. The tangent of 70 degrees equals the opposite over the adjacent. Change it to a proportion, and we cross multiply. And all we have to do here is multiply 67 times the tangent of 70 degrees, and we get that the Space Needle is approximately 184 meters. So this is just like we were solving our triangles last week, but now we are doing it from a word problem and using our angles of elevation and depression. In this case, we used angle of elevation. Let's take a look at this one. An observer in a lighthouse is 69 feet above the water. So what do we need to do first? We need to, one, erase this from previous work, and we need to draw the lighthouse. So here's the lighthouse at 69 feet above the water. He sights two boats in the water directly in front of him. So here's a boat, and here's a boat. The angle of depression to the nearest boat is 48 degrees. So to this boat, we know it's depression, so we have to have a horizontal line. From that horizontal line down to this boat is 48 degrees. Sorry. And then the angle of depression to the other boat is 22 degrees. So from there to this boat, so from here to here is 22 degrees. From here to here is 48 degrees. And if we continue this, hopefully you now see two right triangles. What is the distance between the two boats? So essentially we just want to know this distance here. Well, first we need to find how far away this first boat is. So we're going to find from this distance A. Well, our angle of depression, this dotted line is horizontal to this line down here. So if this angle is 48 degrees, this angle is also 48 degrees. And then we can see we have our opposite and we have our adjacent, which means we need to use tangent. So we have the tangent of 48 degrees equals the opposite over the adjacent. Set up your proportion, cross multiply, and we see that we need to divide both sides by the tangent of 48. So once you make sure that your calculator is in degree mode, this first distance turns out to be about 62 feet. So we know from here to here is 62 feet. Well, now we need to find from here all the way down to the second boat as a distance B. So the only thing that changes here is our angle. Because if this angle is 22 degrees, then this angle is 22 degrees. So now you can rewrite your equation. Let me give me some room here. We can now say the tangent of 22 degrees equals the opposite over the adjacent. Set up your proportion, and now we cross multiply. We are still going to have to divide by the tangent of 22 degrees. So we get that the length of B, or the distance from the lighthouse to that second boat, is approximately 171 feet. But remember, the question just wanted to know the distance between the two boats. So we need to now take distance B minus that distance A. And we get that the distance between the two boats is approximately 109 feet. These can be a little tricky because you have to pay attention to where the angles of depression are, and then make sure you transfer them down to the triangles correctly. So now I want to give you a chance to try them out. Pause the video and answer this question. Hopefully you drew a picture first. Since we're in a plane that's at an altitude of 3,500 feet, we can draw a pretty little plane with our wings and the tail, and it has an altitude of 3,500 feet. And the angle of elevation from the airport to the plane is 29 degrees. Now hopefully you understand that our airport would be on the ground since our plane is in the air. And our angle of elevation, since it told us elevation, is 29 degrees. What is the horizontal distance between the plane and the airport? And then you notice we have our opposite and our adjacent, so we are still using our tangent. So the tangent of 29 degrees equals the opposite side over the adjacent side. Set up your proportion, cross multiply. And in this case, we're going to have to divide by the tangent of 29. And you should have gotten that the airplane and the airport are approximately 6,314 feet apart. You should be thinking to yourself, is this answer reasonable? If you remember that if you're in the sky in an airplane, altitude of 3,500 feet, and you're looking at a very small angle, yes, the airport is going to be farther away. So yes, our answer is reasonable. If it doesn't make sense, go back and double check your work. Let's take a look at another one. Pause the video and answer this question. Let's see how you did. Let's take a look at using our angle of elevation first to find this part of the sculpture. Well, we know this is 12 feet because it's the same distance as down here. So we're trying to find x. We are going to use the tangent, which equals the opposite over the adjacent, create your proportion, and cross multiply. You get that this part of the sculpture is approximately 7 feet tall. Now let's see how you did with the angle of depression. From here to the base of the sculpture is the second part that we need. Well, it told us the angle of depression from her eyes down to the base of the sculpture is 22 degrees. Now remember, with the angle of depression, this angle and this angle are congruent because they are alternate interior angles. So now we can find this distance, which is also y, by using tangent once again. So now the tangent of 22 degrees equals the opposite over the adjacent. Set up your proportion and cross multiply. And when you do, you get that this part of the sculpture is approximately 5 feet tall. So now to find the total height of the sculpture, you should have taken both parts, so 7 feet plus 5 feet, and gotten that the sculpture is approximately 12 feet tall. If you have any questions, make sure you make note of them in your notes and bring them and put them on the parking lot in the classroom. When you come to class, we'll get some practice using our angles of elevation and depression. Good luck!